Up next, the discussion is going to be what you should monitor and alert on in a production system. Ladies and gentlemen, please put your hands together for Arup Chakrabarti.
Wow, I've never had that many people clap for me at once. It's great. It's a very good feeling, actually. We okay? Okay, good. Like Emmett said, the title of my talk is What You Should Monitor and Alert On in a Production System. But as you'll very quickly see, the title should probably be What You Should Not Monitor and Alert On in a Production System, as I'm going to be highlighting a bunch of patterns and anti-patterns in my talk. So like Emmett said, my name's Arup Chakrabarti. As you can tell from the bright font, I work at a company called PagerDuty. Quick question, how many of you guys have ever heard of PagerDuty before? Okay, a couple of hands. Okay, that's better than what I thought. Just for a little bit of context, PagerDuty, basically, we hook into your existing monitoring systems like Nagios and whatever you're using, and we take care of that last mile problem of making sure that the appropriate person's woken up at the right time of the night. So we support on-call schedules and things like escalation policies. So if someone's asleep, it'll rotate to someone else, really making sure that the incidents never get dropped on the floor. Before PagerDuty, I used to work at Netflix, where I managed an engineering team, and before that, I worked at Amazon, where I managed engineering teams and also worked as an operations engineer. At PagerDuty right now, I'm heading up our operations engineering group. Another note about my talk, there's my Twitter handle, and you'll see it also in the lower right for the rest of the talk. If you have any feedback throughout the talk that you want to send live to me, feel free to tweet directly at me. As I'm saying that, I'm going to leave my phone over here, so I'm not tempted to reply to your tweets in the middle of the talk. Negative, positive, any feedback you want to give, I welcome all of it. And then there's a quick disclaimer that I have to also make. These are not for random people that I took pictures of. This is the team that I get to work with at PagerDuty every day. And so a lot of the ideas and principles I'll be talking about throughout my talk, they're not all my own. I've been very fortunate to work with a lot of brilliant people at my current job and in previous jobs, and I want to make sure that I give them the appropriate amount of credit. That being said, if I say anything that upsets you or pisses you off, that's me. So anything good, that's them. Anything bad, you can come after me. So what are we going to be covering today? So first, I'm going to start with the story. I like telling stories to try and articulate what the problem is. And then we're going to try and define what is the actual problem that we're having right now. And then I want to walk us through, kind of how did we get into this mess and, where did this problem come from? Then we're going to talk about how we can avoid the problem going forward for new services with regards to monitoring and alerting. Then we'll talk about what you can do right now to start fixing the problem. These are just shifts in ideologies, maybe it's a couple of small config changes, no new code or anything that you have to introduce. Then I'm going to try and predict the future and tell you guys what I think is going to happen, and we'll see how accurate I am. And I'll make sure to leave some Q&A at the end. And I'm also mindful that I am the last presentation of the day, so we probably won't go for the full 50 minutes, but I'll try to make sure that we have plenty of time for questions at the end. So with all that said, let's get started. So story time. I'm going to tell you about the sad tale of John. John is a completely fictitious name. That's not what the actual guy's name was. His name was George. But we're going to use John for now, so we don't confuse the two. So meet John. And for those of you keeping score at home, Professor Frink from The Simpsons, his first name actually is John, so that's why I picked him. So this is John. He's a software engineer, and of course he enjoys his job, right? He's a software engineer. How could he not enjoy his job? He owns a 24/7 service like many of you guys. Just because he goes home at night doesn't mean customers aren't using the service. It's constantly running. And he participates in an on-call rotation 1 week out of every 4. So once a month, he's on call for a week, which isn't too bad. And John's doing pretty well, actually. He has proper monitoring and alerting for his service. He knows when it's up. He knows when it's down. He knows when it's a degraded state. And he even has proper deduping on his alerts already. So John's already ahead of the game. He's already doing a pretty good job with his service. And then the service starts to scale up. Customers start to use it more and more. And of course, what happens? Outages increase. Why? Because the service wasn't designed for this. So all of a sudden, we're having more outages. And we start creating more proactive alerts. And I'm going to emphasize the quotes again, proactive alerts from each of these outages. And why? Why were we creating these alerts? Well, it was because from every outage, we would always ask ourselves, well, was there a way we could have detected this faster? And so someone will say, well, before the service went down, yeah, memory spike. Slap an alert on that. Fantastic. Next time the outage happens, it has nothing to do with memory. Oh, CPU spike this time. Fantastic. Slap another alert on that. And slowly but surely, we're getting more and more alerts from all these outages that keep happening. So this is happening in John's professional life. And meanwhile, in his personal life, John gets married. He has a girlfriend. He settles down. He gets married. But guess what? His wife is not too happy. And as we all know, the magic formula for successful marriage is unhappy wife equals unhappy life. So Things his wife's not too happy. John's getting stressed out at work, and what does this result in? John has to sleep in the basement during his on-call. I kid you not. It absolutely broke my heart when I heard of this, that John and his wife specifically created a bedroom in their basement because when he was on call, neither of them got any sleep. So the wife kicked him out of their bedroom and forced him into the basement. So that's why I like telling the story, because it really highlights the personal implications of this problem. So what is the problem? Besides, obviously, we don't want to be sleeping in basements all the time. Quite simply, too many alerts. We're getting too many alerts, and we just talked about one of the inputs from the outages. We create more alerts, but really, it's that simple. We have too many alerts, and why is this happening? So in this case, I just talked about each outage. We created a new set of alerts. Again, there was memory, CPU, disk, whatever metric we could come up with that we thought was a precursor to this event or outage happening. We'd slap an alert on it. But here's the problem: there was no pushback on any of this. We never thought for a second, well, wait a second. Is this going to be helpful later? Is this actually going to be a useful alert later on? And we did zero analysis. One of the wonderful things of using a service like Nagios or any other metrics collection system is that you could always backplay an alert. You could say, okay, we're going to see if memory actually has an impact on the site going down. You could have gone back a couple weeks to look at a previous outage to see if you saw the same kind of behavior, and you probably didn't see it. So all of a sudden, you're trying to find all these random precursors to these outages and not actually doing any analysis whether they actually mean anything. And surely enough, over time, what ends up happening? These alerts become meaningless, right? We all know that feeling of, well, the screen was always red, so I just turned off the screen. We all know that feeling of, oh, in the middle of the night, it's 3 in the morning, you get paged, oh yeah, it's a known issue, just resolve it, not a big deal, right? But over time, we become numb to these things. And I'm going to tell another really quick story. Again, I really like stories. So there's a story of this is not meant to offend any Germans in the room. There's a story of a 1960s German art thief where basically he wanted to steal a painting at this heavily guarded museum. And so he tries to come up with a clever infiltrate at night or anything. Doesn't do any of that. All he does every day at 2 in the afternoon, he goes and trips the alarm. Every single day. He goes in, trips the alarm, police come, art thief sneaks out, nothing really happens. Days go by, every day, 2 o'clock, keeps tripping the alarm. Weeks go by, every day, keeps tripping the alarm. After about 6 weeks, guess what happens? The police don't show up. Why? Because it's an alert that's malfunctioning. Yeah, it's a known issue. And he just walks out with the art piece. And so I'm not trying to say that we're German art thieves or that we're police in this scenario, but I'm trying to highlight the idea that it's very easy for our alerts to become meaningless and for the actual problem that could be happening for us to completely ignore it. And that's really, really dangerous. So how did we get into this mess? And it's tempting to blame, oh, it's all big data's fault, and we're collecting too much data. But that's not the only issue. So I'm going to argue that there's really 2 things that's causing this problem. So one, computing's getting cheaper, and automation is getting easier. When we think about infrastructure automation frameworks like Chef, Puppet, CF Engine, or anything else, it's getting so easy to start collecting metrics. These are 2 commands. That's all you need to spin up an instance in AWS and start collecting metrics on it. You're literally collecting tens of metrics per minute by doing this. And when you start multiplying that out over hundreds, thousands, tens of thousands of servers, you're collecting just incredible amounts of data so quickly with really just relative ease. I mean, remember even 10, 15 years ago when you're compiling stuff by hand editing config file, you don't have to do any of that stuff anymore. Even compared to 5 years ago, this stuff is so much easier now. And another thing that's not helping here is that businesses want to collect everything. We keep reading about how big data analytics is what's going to separate successful businesses from non-successful ones, that they're treasure troves of data that are just waiting to be tapped to understand your users. And so what ends up happening is that whenever there is an opportunity to measure and collect data on something, we do it because we have this firm belief now that, well, it's going to be useful at some point, so let's just start collecting it. This is a very scientific graph that I created actually there's no actual data going into this. It's complete made-up numbers, but basically trying to illustrate the point that computing is getting cheaper at this rate, but the amount of data that we're collecting is increasing geometrically. And this idea that we're going to try and alert on every piece of data and have it be a linear relationship between the number of alerts and the amount of data we're collecting, it's a bad idea. And the reason is we're going to go crazy. There's not enough of us in this world to manage these alerts at the rate that our data is increasing. And so here's how some companies are trying to deal with this. So one is, you staff up with 24/7 NOCs, which, if you're a tier 1 ISP, makes perfect sense. You need that level of response time. Another thing is what most companies are doing is that your engineers just don't sleep. And going back to the example of John, we had another team, I kid you not, their on-call was so bad, their on-call would go from Monday to Sunday, and they wouldn't sleep that entire week, and then they'd have to take that following Monday, Tuesday off, and then the following weekend off also, just to try and catch up on the sleep. So, the productivity loss from this is immense. And then the last idea that I'm seeing more and more is that teams are bringing up follow the sun teams. This is the idea where you have a local team, say you have a team in the US, and then you have a team over somewhere in Europe or in Asia that's separated by time zone, with the idea being that you have on-call engineers who are awake when the sun's up, and that's when they're on call. This is a picture of Visa's NOC, Visa, the payment processor. This was a picture taken out of The Guardian, I think it was about a year or two ago, and they were talking about how proud they were of this NOC. And I remember looking at this picture and thinking, wow, that's a lot of really well-dressed engineers, and I was very surprised by that. Those shirts and those slacks are way too nice. But secondly, the thing that I was amazed by was, if you look at this picture, each of these guys has, 3, 4 monitors that they're looking at. And I'm going to advocate that this is a bad idea. As humans, we were not designed to look at screens all day. I already have glasses, and who knows what would happen if I was staring even more at a screen. I don't know how much thicker my glasses could get. But as humans, we're not good at image pattern detection like this. This is what computers are really well designed for, and this feeds into why we need to make sure our alerting is as precise and as pristine as possible. So. How can we avoid this alerting problem? How can we avoid the too many alerts problem? And this is in the context of brand new services. So we don't get a chance to build brand new services very often, but these are some guidelines that I'm going to prescribe that if you are building out a new service, what I'd like you guys to be focusing on. Another thing I'm going to, before I even jump into this, a lot of this is in the context of web servers and services. That's just the world that I've been living. It can be translated into even lower level stuff. If you're working at the networking layer, there are ways you can translate these terms into that stack, and I'm happy to talk more about that after this. So for alerts on new services, keep it simple. Only alert on a couple things. The first one being availability, and measure that as a percentage. The next being error rates, also you can measure that as a percentage. And the last one being latency or performance measurement. And if you're at a small scale, and by small scale I'm talking probably less than 100 servers or 100 unique network nodes, then it might make sense to actually measure host level metrics, things like CPU, memory, disk swap, whatever you're measuring at the host level. But beyond that, when you're at a bigger scale, you really don't care about single node failures, because you need to design your services and system to account for that. So let's talk a little bit more about availability alerting. There's a common misconception about what availability means, and I'm going to argue that really what availability means is that your customer cannot access your service. What a lot of people are tempted to do is, they'll have a ping check going against a load balancer that's just saying, is the load balancer up and running? But that's actually useless when you think about it. Your back-end web service could be down, your database could be down, and you could be serving up 500s the entire time, but that ping check is still going to respond. So the way that I like to think about availability measurements is really think about this idea of a deep ping methodology. So actually trying to measure things like, can the customer log into a site? Can they actually buy something? Can they place a trade? Can they actually do what they came to your website or to your service to what they actually want to do in the first place? And if you're working on a website, things like Selenium testing, you can actually leverage to run that continuously with like a dummy account to see if it's actually working or not, and see if the service is actually doing what you think it's going to do. And then the other element around availability alerting is trying to figure out, what does your business need from an availability standpoint? So in the case of like a stock trading platform or something like an e-commerce website, you obviously have very high availability requirements, right? Which intuitively that makes sense. If you're not up, you're not making any money, and chances are you're losing money, because just because the site's down doesn't mean you can't pay your engineers, right? Sorry, that's meant as a joke. But for something where maybe you do have more lax availability requirements, it's okay to have a lax availability also, because they're just different engineering trade-offs that you have to make in terms of availability and the cost that goes into it. Typically, what I've seen when a team tries to go from one magnitude to the next, from like 2 nines to 3 nines of availability, it takes roughly double the amount of engineering effort. Again, that's a very unscientific analysis that I've done. It's just what I've seen over the years in terms of teams wanting to improve the availability of their services. I have some water here. So for error rate alerting, one thing that I want to point out is that error rates are not the inverse of availability. There's a common misconception that if you're 99% available, that means you have an error rate of 1%, and that's not true. Going back to the idea of the load balancer serving up 500s, if you're doing a basic ping check, for example, that load balancer is probably still up and running, but if you're serving up 500s, your error rate's actually at 100% right there. And so the way I think about error rate alerting is that a customer gets a response, but it's not the response that they wanted. And so if they go to log into your website and they get a 500, or they get a misrendered page, or they get an error message for whatever it is, that's not what they came there to see. Very few websites have very funny 404 pages that customers want to see. And then around performance alerting, this is where it actually does get a little bit more complicated, because when you think about performance, it's not as binary of a number. From an availability and an error rate standpoint, you're either available or you're not. You're either throwing errors or you're not. But performance is a little bit more nuanced. So I'm going to talk in the context of sort of like web server latency performance and some of the problems that you can run into. So one of the things I'm going to advocate for from an alerting standpoint is that your thresholds should not be based on averages. Averages can be very, very misleading. And what can happen is that you can have a very finite number of customers or requests coming to your stack. They'll throw off the average completely. Hence why we're going to talk a little bit more about percentile-based alerts instead. And if you're not familiar with this, basically percentile-based alerts focus on what I consider to be the worst customer experience and making sure that that's at an acceptable level. So a way to think about this is, let's say at the 95th percentile, your latency response is 500 milliseconds. Loosely translated, what that means is 95% of your customers have a page rendering time of less than 500 milliseconds, whereas 5% has something more than 500 milliseconds. Now, granted, you don't know what that distribution looks like necessarily, but that at least gives you a better picture of what your latency performance is on your site. So to walk through a couple of examples here, so here's a normally distributed data set. We're pretty used to seeing things like this. And if my manager comes to me and asks, hey, what's the latency on our site? And if I say, yeah, it's somewhere between 400 to 500 milliseconds, I'm not really lying here. That's a pretty accurate representation of what's going on here. And if he's going to make the assumption, yeah, probably the majority of our customers have a latency somewhere between 400 to 500 milliseconds. And on this data set, yeah, that's actually fairly accurate to say that. But let's take a binormally distributed data set. And again, similarly, I'm going to say to my manager that the average is somewhere between 400 to 500 milliseconds. But if we look at this data set, that's actually quite misleading. There's that, what's the saying? There's lies, damn lies, and statistics. And this is an example of what I consider to be a damn lie, because what's happening here is I'm actually misrepresenting the data set, because now my manager's going to go into the world and he's going to say, yes, our website has an average performance of somewhere between 400 to 500 milliseconds, and a customer is going to come up to him and he's like, no, that's not true. I'm somewhere in the 800 millisecond range, and he's going to be able to talk to a lot of people in this upper range here because we have so many customers on this other end. And so if we look at this from a percentile-based alerting threshold, for the normally distributed data set, the percentile-based threshold still works. So if we look at our 95th percentile here, it's somewhere between 700 to 800 milliseconds, and our 99th percentile is somewhere between 900 to 1,000 milliseconds. So if I set up my alerts there, I can definitively say, yes, 95% of our customers are having a 700 millisecond latency or less on our stack, and then 99% are having somewhere around 1,000 or less. Another interesting piece of data that you can take from this is if your 95th percentiles and your 99th percentiles are very far apart, that tells you that you have a very long tail on your distribution of your data. And that's okay. That's not necessarily a bad thing. And one of the things that taking this approach actually forces you to do, it forces you to ignore that long tail. And don't get me wrong, it's not that I want to say, forget those customers, but you're going to have to get to those later. And the reality is you can only focus on a certain portion of your customer set at a time, especially from an alerting standpoint. And then when we look at binormally distributed data, the percentiles work even better. Again, this is where setting up the thresholds here give me a better representation of what's going on with my customers and their latencies. And while, yeah, there's a bunch of stuff happening to the left of these thresholds that it's not that I don't care, but I have to draw the line somewhere as to where I'm going to set up the alert. And this is a better static threshold that's not going to change that often, so it'll be more meaningful in actually setting up your alerts. So we just talked about new services. But let's talk a little bit more about what can you start doing today for your existing alerts. It's quite simple actually. Just turn off all the alerts. That's right. Isn't that it? Okay. It's not that easy. I know. It's not that easy. But one thing I will say for newly created alerts on your existing services, think a little bit differently about them. I understand you can't go through and rejigger everything immediately. But a couple of points I always like to make is always make sure that you're alerting on things that your customers actually care about. And depending on which team you're on, the definition of customer is going to be a little bit different. For example, on our operations engineering team, our immediate customers are our other engineering teams within the company. And so we actually alert on things like disk latency spikes on our Cassandra boxes because we know that our engineering teams are going to care if our Cassandra performance isn't as good as it could be. But let's say you're a front-end engineering team, you're going to care about client-side rendering time. If you're a back-end engineering team, you're going to care purely about latency of your service. But that's something that you have to figure out is, what do your customers actually care about? And that's what you want to be alerting on. Another thing, and going back to the example of John, you have to resist the temptation to alert on everything. And I know it's the siren song, right? This idea that we have alerts on every single little graph, on every single metric out there. So we could sit at our desk and feel secure that if anything happens, that we're in good shape. But there's so much problems with this from that meaningless alert standpoint that you're going to get all these alerts and they're going to become meaningless. You're going to start seeing so many meaningless alerts, and over time you're just going to start ignoring them. And then another point that I always love to make is making sure that the alerts go to the right people. If your database is down, the alert should go to your DBA. If your load balances are down, it should go to your network engineer. And the point that I was trying to make is that you have to remember, customers, your end customers now, they don't care who gets paged for a problem. They really don't care. All they know is they went to a website to go buy something and your service timed out, which is the effective equivalent of saying, no, keep your money. We'll figure out another way to make money. And that's ridiculous. And so making sure that the appropriate alerts are going to the appropriate people is super important because that way you get that precision and you maintain that sense of urgency when someone gets that alert. And for some of this stuff, especially that first bullet point around figuring out what your customers care about, go talk to your business guys. They are actually pretty useful. And sorry, that's another joke. Come on, guys. I'm sure you guys have sales, marketing, finance staff at your companies, and they can actually be very insightful in trying to help you figure out, what do your customers actually care about? And you'll probably learn a thing or two of that. Maybe you're alerting on the wrong things, and maybe the assumptions that you made that maybe your customers don't care about CPU performance as much as you thought. So going back to turning off existing alerts and being able to sleep a little bit easier, the first thing is you got to collect alerting data. And this is something at PagerDuty we're explicitly trying to solve this problem. But what I always tell people, within 30 seconds, you cannot answer how many times per week you're getting paged. That's bad. You need to be able to answer that quickly. And I don't mean jumping into an Excel sheet, doing a pivot. No, you need that data readily at hand because unless you can measure that data and collect that data, you can't improve it. That's just the bottom line. Unless you can measure it, you can't drive that number towards zero. And then another way to look at alerts on a per alert basis and trying to figure out whether you can turn them off or not, there's a couple of questions you can ask. So first off, was any action taken? Did you get woken up? Did you look at it and say, nope, resolved, not an issue? Well, that means you didn't do anything about it. Next question, was a customer actually affected by this? And again, customer being your immediate customers, not necessarily your end customers. So maybe CPU, disk space, whatever spikes, and then you go in and do something. But if a customer didn't notice, you got to try and understand, well, maybe is this the right alert threshold or not? And then the last one, this might be a little bit controversial, but it's a question as to whether this problem was fully within your control. And for a lot of companies using more and more shared computing environments, cloud infrastructure, shared colos, whatever, we're running into this more and more where the best we can do is file a ticket against like another company or another team or something, and we kind of have to sit there. And so, you know, I'm going to ask you guys whether it makes sense to alert the entire company or the entire team when something like that happens. Maybe it only makes sense to have 1 or 2 people awake at the helm to make sure that when things do come back up that everything does. But in the case where it's a problem where you don't have full control over the entire stack, it might not make full sense to make sure everyone's awake for the problem. Another thing that I always tell people too is that you got to try and fix problems quickly, and this is because you're going to lose the sense of urgency very quickly. A common workflow that I always love seeing, especially for the engineers at our company, is that an alert will come in at 3 in the morning, and you know they either take action or they don't on it. But then the engineer validates that's not an issue. And the following day, they fix the root cause. So what we've done is we've made sure that when an engineer is on call during that week, that they actually have the extra cycles during that week to actually fix these problems that come up. And we call it buffer time, extra cycles, whatever you want to call it. But you want to make sure that they have that time to address these issues. And if it does require a longer-term fix, like a re-architecture or redoing an entire network map or whatever, make sure you start tagging these alerts at the very least. Because what you want to start doing is you want to see where your pain points are. You want to see where the next time you do a planning meeting and trying to figure out, hey, let's pay down some of this technical debt, you can actually look at a spreadsheet of number of alerts sorted by what the issue was, what the root cause was, so you can actually figure out what the priorities need to be around fixing them. Another way to improve your alerting is to improve the signal-to-noise ratio and avoid thundering herds. A very common problem that I see is where, let's say you have 1,000 servers hooked up to a single router or switch. That switch goes down. Now you have 1,000 servers telling you, hey, I have a problem. Again, the worst part about this is that you could actually end up missing something really important in that 1,000 alerts that just came in. It's very easy to bulk resolve all 1,000 of them. And again, Nagios is making this super easy now, but the risk is that you can, another single alert might have snuck in there that you're going to completely ignore. So deduping alerts and aggregating them together is super important. Another anti-pattern that I've seen that I'm going to call out, and I hope no one's doing this here, but avoid what I'm calling the everything is okay alarm. This is where, again, you're going to laugh, but I've seen teams where they're getting so many alerts that they're now ignoring them, so they become meaningless and they're numb to them. So they're ignoring these alerts. So they create another set of alerts where if they don't get this alert every 5 minutes, then there's a problem, which again, it's good. I'm glad you guys are laughing, because when I first saw this, I'm like, oh, this is a joke, right? And then they showed it to me. I'm like, oh gosh, I cannot believe this is the way we're doing this right now. The last thing I'm going to also make is the point I'm going to make is that you need to make sure you're also using the right monitoring tools for the appropriate data that you're trying to collect. So for time series data like metrics data, so Nagios spits out all this wonderful time series data. It belongs in a metrics data store, and that's makes sense. But event-based monitoring data does not belong in a metrics data store. And I'll give you an example. What I see a lot of teams doing is that they need cron monitoring, right? So cron runs, and they need to make sure that it's always running. So what they do is they'll have a cron shoot out like a 1 or some sort of binary signal at the end of the cron completion. So every 5 minutes, it's 1, 1, 1. It's publishing that number to the metric store, and then when it hits either 0 or nil, then the alert fires off. But I'm going to argue that that's not actually what that was meant for. Metrics and time series data stores were meant for things that are constantly changing. So a better way to manage cron alerting in this case is to actually have it publish what's called an event to some sort of data store. And because an event it has no concept of duration. A cron completing is like an impulse function that it happens in a point in time, and there's no duration associated with it. So there are tools out there that allow you to publish these crons, or publish the cron completion to an event-based data store, and then you can run a query against it saying, hey, did my crons complete within the last 5 minutes? No? Okay, then fire off an alert from it. Another area that I'm going to talk about in terms of I spelled metrics wrong there. That's quite embarrassing. Around visualizing metrics, making sure that you're using the right display for that. And this is where sampling rates matter. So for numbers that don't change very often, feel free to use static numbers. This is an example of the number of Cassandra nodes that one of our services is seeing, and the number is always 5. It doesn't really change very often. So this is where we've decided it doesn't actually make sense to look at like a graph or anything. Looking at the static number makes perfect sense for us, and having a color code around it works really well too. So if this number goes to 4, it turns yellow. When it's at 3, then it turns red. But obviously for things that change very rapidly, things like CPU, latency, whatever time series data you're collecting, graphs make more sense here. You want to see trending. If there's an event, you want to be able to see, has it been getting worse, over the last 5 minutes, or has it been getting worse and worse over the last couple of weeks? So I'm going to try and predict the future now. We'll see how well I do here. So what's coming in the future that's going to make our lives a little bit easier from a monitoring and alerting standpoint? So the first is, what I'm seeing more and more of is non-threshold based alerting, and aka what I consider to be non-brittle alerting. We all know that the common alerting pattern is if CPU is above 60%, yes, fire off an alert. And let's say your baseline's around 30%, yeah, that value kind of makes sense, right? So it doubles, yeah, I want to know when that happens, so 60% fire off the alert. But what happens when that CPU usage drops down to 10%? Let's say you've upgraded your servers, more efficient code, whatever it is, and now you have a different baseline. I guarantee you forgot to update that alert. So now that CPU usage has got to spike to 30% now, which isn't going to trigger that 60% alert anymore, and you've missed a problem because the threshold hadn't been updated. Whereas what this is trying to do here, and there's a couple of companies trying to do this right now, is this idea of windowing and constantly creating a new baseline constantly. So on this window on the left here, what's happening is it's coming up with an average or a baseline of what this metric should always be at. And then it sees a spike. And the spike can either be a couple of standard deviations above it or a percentage-based spike, but it's constantly updating. And so when the spike happens, regardless of what the numbers are, it'll trigger an alert. And the nice thing about this is it's self-updating. You don't have to constantly go in and keep rejiggering with your alert thresholds when you have some performance increase or something else improves. The other really nice thing about this is that it's very tunable as well. You can tune it to different percentiles, different standard deviations. The one risk with this, of course, is let's say you have a slow trending problem where over weeks or over months it's slowly getting worse and worse and worse. You're not going to have this kind of spike that's going to trigger the alert. So that's where you definitely have to be a little bit careful with this. Another way that we're seeing more and more is another alerting method is correlation-based alerting. This is the idea where only tell me when multiple things are breaking. And this is super valuable from a standpoint of, let's say you're trying to figure out if you have a latency spike here, a CPU spike, and a memory spike here. Well, yeah, then that intuitively makes sense that something's probably wrong in the system because a bunch of different things are breaking. Whereas if only one of these boxes was having a problem, well, maybe it's just a transient spike in the network or something else that's not fully within your control that you can safely ignore. And then lastly, this is still fairly new, but it's kind of what I'm calling prescriptive alerting. And what's interesting is we're sharing more and more of our computing infrastructure. We're starting to see that architectures are starting to look more and more alike. We're starting to see these best practices and these patterns emerge. And so what's happening is you're seeing companies like AWS or Heroku, and they're the ones that are now saying, hey, your software that you built or something that you built on top of this is having a problem. And what's kind of interesting about this, there's an interesting privacy implication around this too, because what they're doing is they're actually collecting data from all these different customers of theirs, and they're sharing it, again, in an anonymous way, but it's going to be interesting as this emerges over time, as we're sharing more and more of our computing infrastructure, and our platform overlords are collecting this, how they're going to use this data. And it will be an interesting debate over the next 2-3 years, I think. So yeah, and that's what I think is going to start happening in the next 2-3 years. So thank you very much for your attendance today. I've been here for the last day and a half, and it's been just absolutely great talking to like-minded people about metrics and alerting. I've had absolute blast. It's an absolute privilege for me to be talking from you guys today. So thank you very much. One thing I do have to point out, or else my company will kill me, we are hiring. So if you know anyone that's interested in working on high availability or highly automated systems problems, please feel free to get in touch. And now we have time for some questions, and I have T-shirts. So if you want a T-shirt, feel free to come bug me.
Any
Thanks,
questions
guys.
or comments for Arup? Is there anything you're currently working on or developing now that you'd like to share with us?
Sure. So so at PagerDuty, one of the things that we're actively working on is this sort of alert deduping problem. And so Right now, we have some very simple mechanisms for aggregating alerts. And soon in the future, what we want to be doing is a much more intelligent aggregation of these alerts, and trying to apply some machine learning techniques such that we can accept all these incoming events and alerts from your existing systems like Nagios or any other monitoring system you're using, and then we'll be able to tell you, hey, here's where the problem's actually happening, actually trigger the appropriate alert, and then we could also do some smart, intelligent routing to make sure it's going to the appropriate team for you guys as well. So that's some of the stuff we're working on. I think it's pretty exciting stuff, and hopefully within the next 6 to 9 months, we'll be able to get some of that new functionality into the product.
Any other comments or questions?
I answered all your questions. Fantastic.
I guess if that wraps it up, let's hear it for Arup.
Right,
Thank
thanks,
you.
Guys.